So in this video, I am going to show you the pre-processed data based on different date formats. So with the LubriDate, you can easily convert different types of date formats into a date component. So for an example, when you get a data set, the particular date and or the time can have a different format. For an example, in this you have year, month and date. So there in this one you have the first you have the month and then the date and year. So these are different formats. So with the LubriDate you can get those information or the date formats into a single standard date variable. So if you can use the YMD function if your date, particular sample date is in this format, if the year is first. So if your sample date is in this format where month first, day and finally the year, you can use the MDY format. In addition to that, you can use time zones also. Both of these are almost same, which the month followed by date and year. And also there is another format, there are certain instances that date comes first and then month and year likewise. So if you want to assign a date or a time, standard way of time, you can use this function ymd_hm. So in this way you can differentiate various time formats. However, you can get it into a unique date format in the R. So we'll run this again. So in here you can see even though our main string of the date is a different format, all these outputs are same format of a date variable. So using after you convert it into a particular date format, you can easily extract various components such as year, month and date. So you just have to specify the year if you want to extract the year. So if you run this, the reason is first of all we have to run this one, and then you see you can easily get the year out of the corrected or the pre-processed date format, and likewise you can month and also the day. So in the next example I'll show you how you can utilize these functions to a real CSV file. So for this example I have selected this airplane crashes dataset given by the data.world website. So in this dataset you can get the full history of airplane crashes throughout the world from 1908 to present. So I have not actually used the entire dataset for that. I have filtered only certain datasets, around a small number of datasets for this purpose. So when you look at the date, you can see it has a quite different data format which is different from the standard date format of the R. So it doesn't matter because with the LubriDate library we can convert this particular date format very easily with the simple function that we have discussed earlier. So if you look at this particular data set, you can see the month is the first variable and it followed by the date, day and finally the year. So month comes first, then day and finally the year. So if we open this data set, so first of all I set the work directory and then read the CSV file. So if you get the information of the first 6 components or the first 6 rows, you can see the date format is a different date format than the standard date format. So we have to first convert it into a standard date format like we did earlier for a single day. So for this example and considering the data type, I'm going to use this DMY function to convert this into a standard data format. So if you look at the class, it denotes as a factor. So if you are working with time series data, we have to convert this data set into a date format. Therefore, we can do that by specifying this format mdy format, because it is the format in the CSV file, and create another column specifying the date format. So we'll run again, and you can see it has added to another variable or another column. However, in this time, you can see the standard way of representing date in R. So if you look at the class of that variable here, you can see it gives as a date. So previously it was a factor, however now it is date. So we can conduct now the pre-processing is complete because we have converted that date to a date variable. So like I have mentioned before, you can extract year, day, month and day to separate columns of this data set. So if you look at the updated data crashes data set, now you can see there are additional columns included into the dataset: year, month and day. So likewise, we can extract each component and assign it to a different row of the dataset. So, and also after doing that, we can get mean values also. So for this example, I am going to aggregate this dataset and get the mean crashes or mean number of fatalities for each particular year. So we can do that. First of all, you have to assign the component which you are going to calculate the mean, and you have to give the filtering parameter, which is year in this case, and then you have to specify the data set, and in here you have to specify the mean value. So you can also apart from mean, you can also mention sum also. So first of all, I'll show the mean value, how the data set comes. So here now you can see it has given the fatality count, average fatality count for each year in the data set. So we'll change this to into sum. So now you can see it gives the sum of the fatalities for each year. So finally, what I want to emphasize is that when you are working with any data set, any CSV file which contains time series data, the first thing that you have to do is convert the relevant date variables into date format, because once you get the relevant CSV file into the R Studio, it won't recognize as a date format initially, but as a factor. So you have to identify the correct date format and use the relevant function and then to convert into a date variable. So that's it from this.